Okay, so we're looking at organizing and displaying data today. So again, it's in the same work package that you've got. So I will share it here. So we have different types of data. So we've got numerical, so quantitative, and in categories, so qualitative. So numeric variable is a variable that takes numerical. I need to type this out here. So numerical values for which it makes sense to find an average. These variables can either be continuous or discrete. Continuous variable is a numerical or numeric variable that can have a infinite number of values and in a given interval, measurable with all real numbers. So examples of those are temperature, height, weight, speed. Okay, so they're all measurable by real numbers, and they can have an infinite number of variables. So discrete variable is a numeric variable that can take on only a finite number of values within a given range. So for example, number of dogs, number of goals scored, number of siblings. You can't have like literally 1 million dogs and literally 1 million siblings, right? So make sure to write that down. I'm gonna have to clear it. If you need to pause the video, have at her. So we've got qualitative variable, so a variable that places an individual into one or several categories or groups. They may have categories that are naturally ordered, so ordinal variables, or have no natural order, such as nominal. Ordinal variable is a variable that has a natural ordering. So for example, I'm gonna have to make this bigger here. So when asking people to choose between excellent, good, fair, and poor to rate something, the answer is only a category, but there is a natural ordering in those categories. So obviously, if something is excellent, that would be at the top of the ordering of the category, whereas poor would be at the bottom. So they're in categories, but there's a natural ordering to it that makes sense, that everyone would understand. Nominal variables are types of variable that describes a name, label, or category with no natural order. Okay, so an example of that would be there's no natural order in listing different types of school subjects. So for example, history does not have to follow biology. Okay, so these subjects can be placed in any order. Okay, so I'm clearing this. So we have frequency tables. So to make an accurate picture of data, the first thing we have to do is make piles. So for data, piling is easy. We just count the number of cases corresponding to each category. We can organize these counts into a frequency table. Frequency tables are used to organize data. So for example, we've got grade 12s were asked when their spares were. These were the results. So again, there's no natural order to this. It's just kind of all over the place. So I'm going to clear this so I can move forward. Okay, so these are the data that they gave. The problem with data that is presented like this is that you can't see what is going on. So you have to organize the data in frequency tables to better distribute the data. So we have spare in period A here, and you would count. Okay, so if you were to count, there are 15. Students with spare B, there are 14. Students with C spare, there are 9. Wow, goodness. And for students with spare during B or D period, there are 12. There we go. Okay, so counting the frequency is useful, but sometimes we want to know the proportion. So you're looking at this, and you're like, I don't know what to do with this. Like, awesome, there's more kids that have spares period 1 or A. So I'm going to clear this. So we want to look at the frequency, and that's what, or we want to look at the proportion of the data. So counting the frequency is useful, but sometimes we want to know the proportion of the data in each category. So we make a relative frequency table. Okay, so this shows us the data group as a fraction or a percent for the whole data set. So for example, if we look at students that have spare during A, the frequency was 15. Okay. So if we put that into a fraction, so in total, so we would have 15, my goodness. Weird. Okay. So I'm just going to start a new text here. So you would put it, your 15 over your total amount. So our total amount is 15 plus 14, so 29 plus 9 plus 12. So our total is 50. And then you would turn it into a percentage. So you would do 15 divided by 50 times 100, which would give us 30%. So that gives us more of an idea. We can say, hey, these kids have a spare, or 30% of these students have a spare period 1. If we were to look at spare B, so we said that we had 14 students. So we would do the same. So 14 divided by 40 times 100 is 28%. Okay, spare C, we said that there were 9 students. Okay, so you'll do the same. So 9 over 50, which is 18%. And finally, the D, we said we had 12. So 12 divided by 50 times 100 is 24%. So that gives us a bit more of an idea in terms of numbers. So I'm clearing this and we're going to move forward to bar graphs. Okay, so bar graphs are used to display data. So earlier with the frequency tables, that was to organize your data. So remember that data management looks at organizing, displaying, analyzing data. So this is used to display the data that you have. So bar graphs are segmented bar graphs, pie charts, and pictographs are appropriate types of graphs for displaying the data of categorical data. So bar graphs can also be used for discrete numeric variables. So a bar graph displays the distribution of categorical variable, showing the counts. So the frequency for each category next to each other for easy comparison. So a bar graph consists of parallel graphs of equal widths with a space between each bar, with lengths proportional to the frequency of the variables they represent. Okay, so I'm going to clear this. Okay, so the following frequency table shows the number of different US ratios, radio stations broken up by category based on the kind of music they broadcast. So complete the relative frequency column. Okay, so what you would have to do is you would have to count or add all of these together, and you're going to do this number divided by the total amount. Okay. So just real quickly, so I don't waste your time doing a bunch of math on the screen. This one is 5.56, 8.49, 20.18, 21.28, 8.85, 25.15, 6.11. My goodness. And about 100. So I'm going to clear this. Okay, so use the table to create two bar graphs. The first showing frequency and the second showing relative frequency of each category. Okay. So I'm going to draw these guys out. Oh, dropping things. Okay, so the first one we've got classic rock, which is a little above. What's going on here? Okay. Maybe not. Okay, so that'll go there. Modern rock is a little below 1,000. So you notice how there are spaces between the bars and the data. Country is above 2,000, which makes sense because it's the best. Okay, you color it in like that, and you keep going. Okay. So that goes up here. So this is looking at the frequency numbers that we're giving in the table. So oldies are a little lower than 1,000. It'll be easier for you guys when you're not on a computer. I usually have a tablet, but for some reason it's not working. Okay, pop. You can color that in. Electric or electronic is right here. Okay, so hopefully you've done bar graphs before and this isn't new to you. And we've got hip hop. Okay, so it's important that you have spaces between your data and you're working through like that. I'm not going to draw these, but if you were to do it through the relative frequency of each data that we just wrote down, so that 5.56, 8.49, so on, you would notice that the graphs are the same. So that answers this. Okay. I'm going to clear this and we're going to take a look at pie charts. Personally, pie charts are my favorite. So clearing. Okay. So a pie chart shows the distribution of variable as a pie. They slice the circle into pie or pieces whose shapes are proportional to the fraction of the whole in each category. A pie chart is best used when trying to show a category's relationship to the whole. So pie charts are awkward to make by hand, but technology will do the job for you. Here is a pie chart showing the US radio stations from the previous example. So I'm just going to clear that one word so I can do the pie chart down here. Oh no, it's already done. Okay. Okay, so this is the example. So you can see that it has all of its labels for each. There are different colors and the percentages are there. So it's important that you're writing, that you're calculating those percentages and that they're in full units. So you don't want that 5.59, just throw it in as a 6. Okay. So pictographs is a symbolic representation of data. The following pictograph displays the number of participants aged 15 or older in the 5 most popular sports activities in Canada. Oh goodness. Okay. So here goes pictographs. So how many people aged 15 and older play hockey? So you would look here, ice hockey. So each person represents 100,000. So 100,000, 200,000, and you would count, and it would give you a total of 1,500,000. I'm going to clear this. So we've got another example here. So how many red delicious apples are in the store? Okay, so again, look at your legend here. So a full apple is 10, half an apple is 5. So if we were to count, so we've got 10, 20, 30. How would you represent 11 apples? So based on the scale that we have, based on the scale, it would be very difficult to accurately represent 11 apples. Okay, So this shows us problems that we have with pictograms. So you can't split up that apple into 10 different pieces, right? To give you the legend that you need. So I'm going to clear this. So when we're looking at the problems that we have, so pictograms can make a graph more interesting, but legends are often missing or confusing. Graphics are sometimes distorted or confusing. Relative frequencies are sometimes hard to determine. So again, how would you represent 11 apples? Okay, so I'm going to clear this and we're going to look at the last part of the graphs and tables. So we've got contingency tables and segmented bar graphs. So we have learned some techniques for analyzing the distribution of single variable. If a data set involves two categories, we use a two-way table. So it's called the contingency table. So a two-way table of counts organizes data about two categorical variables measured from the same set of individuals. So only 32% of those aboard the Titanic survive. Was the survival rate the same for all ticket classes? To answer that question, we can arrange the count for the two variables, so survival or ticket class, in a two-way table. So I'm clearing that little bit and we can look down here. Okay, so here's our table. So in this case, survival is our row variable. And our class is our column variable. The margins of the table give totals. So when analyzing a contingency table, the goal is to see if the variables depend on each other. This can be done by looking at the two possible conditional distributions. So our row and column. If we think that class might depend survival, then we should look at the distribution of the row percentages. This is the conditional distribution for class based on survival. Okay, so we're looking at class as in like first class, second class, third class. So same as if you were on a plane. So did it really matter which class they were in? So I'm going to clear this. Okay, so our second table looks at the percentages. So this scenario doesn't always, it makes more sense if survival depends on class. So to do this, we should look at the column percentages. So this is looking at your rows. Okay, whereas our second one looks at our column percentages. Okay. So looking at how percentage change across the rows, it surely seems that class influenced whether person survived or not. Okay, so 62.5%. So if we're looking at that column percentages, of first class percent or passengers survived, while only 25.2% of third class passengers survived. Okay, so I'm going to clear this so I can bring this down. Okay, so this I just talked about. So 62.5% of first class survived, whereas 25.2% of third class survived. So two-way tables are often displayed using segmented bar graphs. Okay, so I'm going to clear this. We're just going to do our segmented bar graphs. So this is the bar graph survived based on using frequencies. So as you can see here, we have the amount of people that are alive from first, whereas that died, and then second, third, crew. Okay, if we looked at it from the conditional percentages, it shows us a little bit clearer. So the numbers are all at the same amount, but it shows us the percentage of the people that survived the Titanic. So the bar graphs of each graph have the same proportions, but it is easier to see in the second graph that first class passengers had a higher proportion of survivors. So it's a little bit more clear and whatnot. So in my opinion, that's what I would use. And then you've got your independent practice questions, and that is all for today. So I hope that it goes well. Your work will be posted tomorrow at 9 a.m. And I do expect to have that work posted in the Dropbox by 3 o'clock so your attendance can be taken. Good luck.